Okay, so we have our vertex. So, and it's at, go back, no eraser. Okay, so it's right there. Okay, so what we want to see is, is this going to go up to, so each time, this is our vertex, this is our axis of symmetry. Axis of symmetry means that everything on the left is going to look exactly like everything on the right. Do better on that axis of symmetry. Yeah. Okay, so everything on the left is going to match everything on the right or be symmetrical. And we're going to go from here, and we're always either going to go, or we're going to go to the left and right of the axis of symmetry, just one every single time. But we're going to go up that many each time. So we go up 2, out 1, each direction. And then from there, up 6, out 1. So up 1, 2, 3, 4, 5, 6, out 1 in each direction. We have to match it. And if you want to, another thing you could do is you go, okay, that's 1, that's 2 away from the axis of symmetry. So the other side's going to be 2 away. So obviously this is the right one because A was equal to 2. So that's the right graph. Okay, we'll go back and answer these questions now. So we're going to compare it to the parent, which the parent function, and I'll just go ahead and sketch that one here. So I can see all these questions and sketch it. Okay, so the parent function, there's no number in front of x squared. So we know that there's a 1 there. Okay, and that's where our 1, 3, 5 would come in. So our parent function, well, first of all, would be over here, the vertex, because there's no, there's no h and k. There's nothing, there's no numbers. It's just like that. That's why it's called the parent function. So it starts at 0, 0, the vertex, and then it just goes up 1, out 1, like that. And then it goes up 3, out 1. So what I'm going to do, though, instead of sketching it right there, I'm going to go ahead and scoot it over and sketch it over here so we can kind of see if it's wider or narrower, compressed, what like that. So hang on a second. Okay. So if the vertex was there and A was equal to 1, it would just go up 1, out 1, like that. And then up 3, 1, 2, 3, out 1, like that. So I'm just drawing it over here so we can see. So you can see that that this, since A equals 2 right here, that this blue graph is a little bit narrower than the A equals 2 is a little bit narrower than the purple one, narrower than the parent. And so what we do is we call that stretched. So that's a vertical. We're going to call that a vertical stretch. So, and then of course, these other, let's see, translation, remember it has SL. So that's when we see translation, we're talking about, shifting it, moving it, sliding it. When you're in elementary school, you call the translation a slide, and SL. So that kind of maybe helps you relate to that. So filling in those blanks, the graph of G is a, let's see, it's only a horizontal translation because remember that the X is flat. The X-axis is flat. It goes left to right, and remember that the horizon is flat. So the X-axis is flat, the horizon is flat. When we're talking about the X direction, we're always talking about horizontal. So horizontal translation, then 3 units left. And then it's a vertical stretch by a factor of 2.
I hate these scales.
So let's ignore the scales and just first start out with finding the vertex. So let's just not worry about the graph and see what the vertex is. Okay, so since the vertex is negative 10, 0, we're just going to try to find which one of these, so here's the origin. Okay, we know that we've got to go to the left 10. So if we're looking at this one, we can't go to the left 10. If we look at this one, did that one move to the left 10 or did it go down? Went down.
It went down.
Okay, did this one go to the left 10? So there's the vertex. And then if we look at the scale here, we've got negative 6, negative 12. Well, that looks like it's pretty close to negative 12. So that's probably a negative 10, 0. So that would be your winner chicken dinner for which graph it is. Now we just need to figure out how to fill in these blanks down here. So for the first choice, we're saying it's so we talked about translation, SL is like your slide. So if we think about this winner up here we slid it over there. So this one would have been at the origin, but we slid it. So we translated it. So which direction did we slide it? Did we slide it vertically or horizontally?
Horizontal.
Yeah, so it's a horizontal slide or translation, right? And then how many units did we slide it? What was our vertex? Vertex was negative 10, 0. So we slid it how many units? That way. Okay. Okay. So A equals 1/4. Okay, when A is okay, so A equals 1/4. So when A is less than 0, or I'm sorry, less than 1, the absolute value of A, so less than 1, which that's a fraction, then it's going to be, it gets wider. So I'm just gonna have to see which ones of these words. So it's not going to be a vertical stretch. Shrinks we don't even use really. So this one's going to be a horizontal stretch. So it stretches it makes it wider. So if it makes it wider, then it's going to be a horizontal stretch. And then that's by a factor of 1/4. Okay, so an even function and an odd function. First of all, f of x equals x squared. That right there is an even exponent. So if it's an even exponent, it's an even function. So this So any quadratics, all quadratics, have that even exponent. So quadratics are all even functions. Now, if a function is an even function, that means it has an axis of symmetry. Okay, so if you have, so in this case, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. Let's do that. Okay, so in this case, we've got f of x squared. So we'll have it like this. Okay, so now if I go out here to positive 1, I get positive 1. If I go out here to negative 1, I get positive 1. So that means that f of, and remember that y is the same as f of x, right? So this is x. So f of positive 1 equals 1, and f of negative 1 equals 1. And then I told you we go like 1, 3, 5. So we are also going to go, so we'll go from here and we'll go up 3. 1, 2, 3, out 1. And then from here up 1, 2, 3 to the left 1. Okay, so this is, so x is 2 right there. So f of 2 equals 4. And f of negative 2 also equals 4. Okay. So in general, what we would say then is that f of x equals f of negative x. See right here? So like if you called 1 x, this is positive x and negative x right there. Positive x and negative x, but they have the same answer. So that's the same as that. That's the same as that. So let's take that and see if we can use that information to to see what they're asking on this error analysis question. So describe and correct the error in determining whether the function f of x equals x squared plus 3 is even, odd, or neither. So this person said, okay, well, they took f of x equals x squared plus 3, and then they said f of negative x equals, negative x in parentheses squared plus 3. Okay. And so then they said, okay, then that just, negative x squared is still going to be x squared. Okay. Plus 3. I don't even really know. Okay. So they're doing, they're doing a little proof here. So x squared plus 3 originally was f of x equals x squared plus 3. And so they're saying, okay, well, then that means that is f of x. So f of x is an odd function. Well, that's right there's where they messed up. Okay, so so let's look. So we know that this is an even function. So really, if we look out here, this last part is not true. This is true. The function is even. Function is odd, not true. Neither odd or even, not true. Okay, so let me just give you real quick an example. So we know that this is the answer. The definition used to call the function odd is incorrect because f of negative x equals f of x. So the function is even. So that's what I explained to you, is how an even function works. But really, what you just need to remember is that the exponent is what makes it even. I'm going to show you an example of an odd function, which would be, we'll just use the simplest one, x cubed. So if we had f of x equals x cubed, then the way that looks, it goes like this. Okay, so so if we went out here to, X, we've got, oh, that's not a good place. Let's move X. Okay, hold on. So if we went out here to X, make that be X, there's f of X. Okay, if we go over here to negative X, and I didn't do it real cool, real even, but it's down below. So it's, f of X. So if this is negative X, then f of this is down. It's obviously not the same. So f of X doesn't equal f of negative X. So that one's, but we knew that because that's an odd exponent. So that's the best way to tell is, okay, if it's an even exponent, it's an even function. If it's an odd exponent, it's an odd function. Now, the one that would be neither would be one that's not a function. Okay, so like a circle, that's not a function because it doesn't pass the vertical line test. The vertical line test would go through more than one point in the graph. So that's the way, if you remember back to the vertical line test, that's how we tell if something is indeed a function at all. All right, now they've given you lots of questions where you just have a horizontal translation or slide. And now we've got horizontal and vertical. So first we have to find the vertex right here for this one. So y equals -6 times x plus 4 squared minus 3. Let's see what the vertex is there. So we got, hold on. Okay. So plus 4 gave us -4 for x, minus 3 out here for k. Gave us -3, and then the axis of symmetry is x equals whatever x equals in the vertex. Now we got to find the graph. So we're going to find the graph. So the first thing we want to do for this one is we want to just make a note of what the vertex is. So the only one that has the correct vertex is the first one. And we know that it's frowny or upside down. Like I said, it's just, I don't know why they don't say frowny, but they have to say reflect. But upside down is because it's a negative. So we're going to take a look down here and see what is going to go in these blanks. So hold on. So remember I talked about reflections. So reflections are like flips. So a reflection, it's going to be reflected because it's frowny, it's upside down. And that is like when you were in elementary school, you learned it was a flip. So is it flip? So if it were a happy guy and it goes to a frowny, is that flipping over the x-axis or the y-axis?
X.
It's flipping over the x-axis. So it's a reflection in the x-axis. And then it's a translation. How many units to the left and how many units up or down? Or how many units left or right and how many units up or down? So it went 4 left and 2 up. Okay. All right. Now we don't have to answer all the questions. We just got to match. Let's see. So let f of x equal x minus 2 squared plus 1. And then match the function g of x equals f of x minus 1. So what we have to do is we have to take f of x and we're going to, hold on a second. So for this one, we just take, since it's the minus 1, since it's x minus 1, so it's saying we're taking f of x, but, you know, we're going to go another minus 1 in there. So we're going to go, we've got our x minus 2, and if we subtract 1 from that, negative 2 plus negative 1 gives us negative 3. So we got to find which one of these is going to be g of x, and it's going to be, so first let's just name the vertex for this. So the vertex is what's the vertex there?
3, 1.
3, 1. So then we just have to see which one of these is that. So this one to the right, 3 up 1 up. That's it. So let's make sure that we didn't. That one's just up 1. So now here's another way to look at it. So that's one way to look at it. Another way to look at it is, let me get rid of all that. And so if we were to graph this first one, we go to the right 2 up 1. So that would have been our graph of that one. Okay, now we take that one and we slide it another unit to the right. So you see how this graph is just that original graph, but slid to the right one?
Yeah.
Yeah. So that's another way to look at it. So that might be an easier way to look at it. Okay. So for this one, so if we look at this one, this original, we'll say this original graph, our vertex for this original graph is 2, 1. Okay, so if we go, our vertex for the original graph is to the right 2 up 1. So actually, let me get a better color, another color. So to right there, so that would be original. Okay, now this plus 2 means that we're going to, remember we do the opposite of that. So it means we would move that to the left 2. So if we move it back over to the left 2, this is where we want our new graph to be. Okay, so we have to look and see which one of these, and it's obviously not that one. So we look over here and see, is it this one, or this one? Yeah, so the new vertex is 0, 1, and this, oops, I don't have my pen on. And this is the one that has the vertex at 0, 1. So that's it. And so if you were going to do it the other way, you would have said, okay, we've got x minus 2, and then this thing's telling us to go plus 2. So that means x would just be by itself. So it would just be x squared plus 1. And then that's the, so that's what gives us the vertex of 0, 1. So that's the other way to do it. Okay. All right. So let's take a look at this one. So in this one, the x, so here's what we do is we compare. So we're starting out looking at this one, and then we want to look over here. Well, this is taking this whole f of x. It didn't change anything inside there. So this is taking this whole graph and then plus 2. So it's moving it plus 2. It's going up 2. So what we're going to do is we're going to say, instead of this one, we've got f of, or actually h of x is what we're calling it. So we're saying, okay, we're saying h of x is f of x. So it's x minus 2 squared plus 1. And then we're adding 2. So plus 2. So we've just got x minus 2 squared plus 3. So let's look at what the vertex would be for that. So the vertex is 2, 3. And we just have to see which one. And thankfully, they've given us a nice scale for these. So we look, this first one, it goes out 3, up 1. Well, that's not what we want. This one goes, out 2, up 3. Looks like that might be our winner. This one goes just plain up 1. This one goes out 2, down 2. So this is our guy. So each time what you want to do is you want to say, okay, is this going to be a change that happens inside the parentheses with x, or does it happen? So really what you're doing is you're just saying, is this affecting h, or is it affecting k? So which one is inside parentheses with x, h or k?
H.
Yeah. And so that one's affecting h. So really, all you have to do, since it's inside there with x, is you just have to say, okay, we're just going to go minus 4 like that with the x. So plus 3 minus 4 is going to give you minus 1. So our new equation, g of x, is going to be x, and then 3 minus 4 is negative 1. So x minus 1 squared, and then that plus 5 doesn't get affected. So then you just have to say, what is the vertex?
1, 5.
1, 5. And you just find the one that has the right vertex. And now they're messing with our scale here this time. But this one's the only one that goes out 1. So there's your vertex right there, out 1. And then it goes by 2s, because that's 4. So 2, 4, 6, 8. Who do we appreciate? Anyway, so that's between 4 and 6. So that would be our winner.
Okay.